Hello everyone, good evening.
Good evening, Kiran.
Good evening. Just give me another 2 minutes to let others in. Okay, are there any questions to me from yesterday's session?
I have a question actually, but not from yesterday's topic. Like
Okay,
probably like I can ask later after if somebody has question.
that's okay. Go ahead. The first
Okay,
five
okay.
minutes I
So
usually reserve for questions.
okay, so this is about the backend database testing, Kiran. Just a suggestion. I want an advice. Like for, if you wanted to go for backend database testing, um, so which one is the preferred for this one Postman actually? Is it the Oracle SQL or the MySQL or my MS SQL, or which is the preferred or how the companies in real time they use which database?
Okay. So using the database technology is purely the customer requirement. And
Okay.
mostly what they look at is the maintenance of the database is something they look at, and which database is easily scalable, easy to maintain. That's what they look at. And this is where every tool that you mentioned, MySQL
Mm,
versus SQL Server versus Oracle, comes into
mm,
picture. Sometimes customer is also interested in a budget friendly database or open source database. If that is the case, then you go for Postgres or MongoDB, NoSQL databases. So the choice of database always lies with the money factor, ease of maintenance, and ease of scalability. So if the customer has decided that, hey, we are using Oracle database, then obviously your backend testing will be on the Oracle database only. And if your question is like which is commonly used across the organizations, very difficult to answer it. But in my experience that I have seen, my developers used SQL Server for a couple of years. Then we migrated to Postgres database. Then we used Mongo database. The Mongo and Postgres are NoSQL databases, whereas SQL Server, Oracle, MySQL, they're all SQL databases where relationships exist between the tables. So
okay.
I cannot purely say this is good, that is bad. It depends on multiple factors. But MySQL is very rarely used now because better than MySQL, you have SQL Server. And if you're going for a very bigger project, such as a telecom project, then they think about Oracle servers,
Okay.
or they think about, example, in IoT, Internet of Things, we have used Postgres and MongoDBs. For small
Okay.
mobile apps that you are developing, yeah, people go for MongoDB and Postgres also. So it varies.
Okay, so you said no SQL. So what is the treatment? So those are like Mongo database and Postgres SQL are no
Uh,
SQL database. So we don't use
so
much
yeah,
S. Okay,
yeah. So this is
well,
what the old database technologies that we are using are SQL databases. So in SQL, relationships exist. Whereas
okay,
in NoSQL databases, you don't need any relationships between the tables, the columns. So NoSQL is the new phenomenon in the industry from last 8 years. So in SQL, you have to follow a lot of syntax rules. In NoSQL databases, you don't have to follow them. Examples of NoSQL will be Postgres. Then you have MongoDB, etc. SQL examples will be our traditional things like MySQL, SQL Server, Oracle. They're all regular tools.
Okay. Okay.
Okay?
If you just go on the SQL part, actually, MySQL or SQL, I think like we can just learn any one of them, and probably the syntaxes might be little different, but the concept would be same, maybe, right? Or
Yes,
okay,
100% same.
okay,
So
okay.
if you learn MySQL, then you will be comfortable in the future with SQL Server and Oracle as well.
Okay. Thank you so much. I think that answers my question. Thanks, Kiran.
Yeah, you're welcome. Okay, welcome everyone. Uh, so yesterday we discussed about client and server architecture, which is very essential for the API testing process. And you will understand the importance of yesterday's session in the actual classes. And we are still talking about chapter 1, and this is the last chapter in chapter 1, which is 3-tier architecture. So when any software project is developed, whether it is a web-based application or a mobile app in any organization, the software engineering follows 3 different steps. There are 3 different phases involved, I would say. So you have the front-end system development, then you have the back-end system development, and finally you have the server-side system development, which is nothing but your database layer. So whenever someone says 3-tier architecture, this is what they mean. And obviously we need to know what exactly we mean by front-end, back-end, and server-side. You'll understand it better now, and where APIs come in also, I will explain you. So when we say a front-end system, it is the GUI layer or the presentation layer. And typically it is rendered on a browser or on a mobile app. Simple example, if I say I have an application called blazedemo.com/login, whatever interface you are seeing now, this interface is called as the GUI layer, whatever interface you see. And this is called as the front-end system, front-end layer or presentation layer.
Wow.
This is what manual testers actually see, and this is what manual testers test in the application when they see it. Okay. So front end is the GUI layer or the presentation layer.
Liver piece వచ్చింది.
Guys, be on mute if you're speaking to someone. Okay. Yeah. Then under the front end system, we have so many things to talk about. Front end system consumes the APIs. It won't develop the APIs. It consumes the APIs developed by the backend system. Okay, I will explain what exactly is consumes APIs because it's a very big topic for the entire class. So I'm just writing some points to make you guys feel comfortable. And basic UI and functional validations happen in this layer. Now, what do I mean by basic functional validations? Example, if I click on login button without entering username and password, the developer who developed this UI will write a simple logic in the code that if email is empty or password is empty or both are empty, but the user is still clicking on login, throw a basic error message that you cannot keep these fields empty. See, when I click on login, I'm getting this error. Please fill out this field. So when I enter something and click on login, password is empty. So this error is coming from this front end only because the browser is not at all refreshing or loading to throw this error. It is coming directly from this particular front end system. That is called as the UI and functional validations, which the front end system does. Okay. And what front end does is after the user has entered the username and password and you click on login button, front end developer, meaning the guy who developed it, in the front end system, we will never know whether this email and password is correct. So when you click on login, what happens is the front end guy will forward this login call, which I will call it as login API call to the next system, which is the backend system. So that is where to transfer that login details, we use the word, it consumes the APIs. And I will say front end will communicate with backend after completing all the front end validations. Only when front end validations have completed and passed, then only front end will talk to backend. What is that validation? Email should not be empty, password should not be empty. When these two conditions are met and you click on login, only then it will talk to the backend system saying this is the email user is typing, this is the password user is typing. Now you check whether it is correct or not. Okay. So then we get the backend system. So what is the backend system? It is the non-GUI layer or the middleware layer where entire business logic is implemented. For the project that you are developing, this backend system is the brain. So backend system is very critical for any project developed in the world. So in the backend system only the entire brainy part of business logic and validations are implemented. And this is where APIs are also developed. Okay. So here APIs are developed so that front end can consume them to talk to backend system. And so once you type some email address like kiran@gmail.com and you typed some password, when you click on login, front end developer says, okay, email is entered, password is entered, both are present, but I don't know whether they are correct or not. To know if it is correct or not, when you click on login, front end says, I'll talk to my friend backend because backend knows what should happen. So here, that is what I said, front end will communicate with backend after completing all the front end validations. Then in backend system, I will say the backend will validate the front end API request. And if the received API request is valid, let us say invalid in the first case, and if the received API request, if the received front end API request is invalid, backend will reject it with 4xx error. What is 4xx error? Yesterday we have discussed client side errors. Okay. Same thing I'll copy. So backend will validate the front-end API request, and if the received front-end API request is valid, what if in the case it is valid? Backend will accept it plus conducts API level validation checks, and then it will forward the front-end request to server. Okay, so backend will also does the validations just like front end does. So backend can also reject it if front end request is invalid, or backend will forward it to server if the request received is valid. Now you might say why backend is forwarding to server? Simple. This email and password that we have entered, front end does not know because front end does not maintain the database. So front end will talk to its friend via the API call of login. Backend will say my job is only to validate the API request, whether the syntax is correct or not, whether the payload is received or not. If everything is correct, it says I don't have the database because I don't maintain it. So I will forward it to the third guy who is backend friend called database or server. So now the server side system comes into picture. And here the database layer exists. The server will receive the backend API request to validate it further. If the backend API request is valid, server will return 2xx response. What is 2xx? yesterday we have discussed successful response. If the backend API request is invalid, the server will return 4xx response. Just like here, 4xx error, I will say. Then, if the backend API request is valid, but server is busy, server will reject with 5xx error. Okay, so I'll use the word PE will reject it with 4xx error. Okay, so this is how the communications happen between front end to back end to database. And if I have to put it in the form of a diagram, I will say this is the front end. This is the backend system, and this is the server side system. So let me say this is the front end system. This is the backend system. And this is the server side system. So a normal user, like a test engineer or a real user, will be somewhere here, the manual tester or a real user. So he will be interacting with this application. With the front end, you are interacting it, right? So now, let us say the front end has validated the request submitted by the user, something like he entered the email and the password, though valid or invalid, and clicked on login. According to front end, the request has passed because the username and password is entered. The front end will simply say, I'll forward to backend. Now what backend will do, or backend or any system, right? If you see here, so here what will happen? Front end validations happens here. After the front end validations are completed, the green color arrow will move from front end to backend. Similarly, the backend phase, I will also have backend validations here, right? And when the backend validations are happening, backend can say the request I received is somehow incorrect. So it can reject it. But in rejecting it, the backend says, I will not even let you go to server. I'm rejecting it here only with orange color, which will be a 4xx error. So this is a clear case of rejection with 4xx. But what if backend says, no, the request from front end is valid? Then it won't reject it. It will say, let me forward it to server. And server says, I will do my own validations here. So here I will say database validations happen here. Database or server side validations, anything. And when server side or database validations happen, it can reject the request, giving the reason as 4xx because the request is invalid. So this is a clear case of 4xx error. Or server might say, no, the request is valid. So if the request is valid, it is giving a success response. In this case, this diagram 2xx. And what backend will do? It will just forward that success response back to front end. Because backend job is a courier boy now. It has to just coordinate between front end and backend. So it comes here. And then once it comes to the customer, the user, he will be happy because he got success message. He's a happy guy. But sometimes the server can reject your request saying, hey, your request is valid, but I don't have time to process it. So this is a clear case of rejection. So this is where 5xx error comes into picture. Okay. So what backend will do? It will simply forward the same request back to front end, telling you know what, server rejected your request, though I forwarded it. And when the request is rejected, obviously the client will not be a happy guy because he got an error message. Server is busy, please try again later, or client error, something over there. So this is how the communication happens between front end to back end. And if you are a manual test engineer, you have been testing this front end only. So manual testers work here. In my career, I worked here in the initial days of my career. In your career also, initial days or currently, you are probably working only in the front end application because that's where you use the mobile app screens or the web application. In this course that you have opted with me, your testing happens here. So API testing happen here. Not only this, the security testing also happens here. Not only this, performance testing also happens here. This is the layer which is main for any kind of crucial testing. Right now, we are focused on this one. API testing happens here. And if you say, hey, my job is to do database testing, then you will use select a star from table, insert query, update query, delete query, and some other logics. And that testing happens here. So I can say database testing happens here. Security testing also happens here. Okay. Yeah. So this one, API testing happens here. So if you are learning this course, of course you are learning now. So you are testing the backend systems. You're not testing the front end now. You're testing the backend systems. So this is about the 3-tier architecture model that we have. Very simple. I did not prolong it much. I did not make it complicated for you guys. I made it very simple so that you understand the theory and the diagram. With this, we have successfully completed chapter 1. Any questions from anyone?
Hi, Kiran, this is Kodai. Since I see like all the errors is going to give is in the mode of HTTP, right? So in that case, API means can only be done only for all the internet. I mean, only it can be through the internet service. If I have internet, then only I can do this API testing because it's everything is with HTTP and then like request client to client to server communication like that. So how do I understand that part?
Okay, so when we talk about APIs, you are actually talking to the server, right? And right, today, when I say today, at least on the last 10 years, you don't know where the server is present, right? In your project or my project or Sarvanan's project, we don't know where server is present. Server is always at a very far away location. I'm testing from India, but my servers could be in Singapore, could be in United States, could be somewhere else. Which means for me to communicate my request from front end to back end is okay, but from back end to server, it is always one continent to another continent, one country to another country, or one state to another state, one city to another city, which obviously brings down a point that without internet, you cannot even test your communication from second box to third box in the diagram. Meaning from backend to server, you are not even we cannot even test it today in the given generation. So when I say or when you say I'm testing APIs, it is default understood that everything is a communication over the internet.
Now, even if it is like anything like what do you call like service bus like that, also it is going to be only through the internet like that. So someone placing the message in somewhere in between, everything is going without internet. We cannot do like that. You are telling, right?
Yes. Without internet, APIs don't exist today.
Okay. But then in phone, like from front end, if it is my phone, right? If it is connecting to the back end, sometimes we go offline, right? So that time also, will that HTTP message will be given, like if it is not reachable?
Okay, see, in some example applications, right? Example, if I say maps, Google Maps, if I take now, I don't know if you have seen these kind of messages on the Instagram Reels or YouTube Shorts, where they said because of the ongoing war between Israel, Iran, and US, if World War III really gets triggered, the internet gets shut down, probably,
Okay.
then people will rush to safer places. And for them to rush to safer places, no one knows what is the route, right?
Yeah.
Right now,
Yeah.
you are dependent on Google Maps, but when internet is down, Google Maps will not work.
Yeah.
So there is another mapping software everyone suggested in the YouTube Shorts or Instagram Reels saying, download this for your family safety, for your friends' safety. So the maps are also available offline.
Okay. 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 Now I got. Yeah.
I
Got
mean,
it.
I'm trying to give an answer to your question. So when I say maps, APIs are definitely necessary, but that particular guy who developed the maps are also available offline, meaning it is still using the API technology, but they have implemented the offline concept way of working also. Maybe they have local caching enabled, or the entire logic is built into the same front end so that, even in the worst case situations, your location coordinate still works. So
Okay.
when I say that internet is mandatory for APIs, my statement is if not 100% true, 90% true. 10%, there is always an exceptions for everything that anyone says in the world. So APIs also exist when internet does not there or is not there. But that's a very, very rare scenario.
Okay.
Okay.
Okay. Yeah.
So
Thank you,
if
Kiran.
yeah, fine, cool. But most probably, right, 90% of the times with internet only APIs exist. I hardly worked on any project where they say we don't need internet to test APIs. In Google also, I saw these funny answers when someone says, what is the difference between web service versus APIs?
Yeah. Yeah.
Someone said web services need internet, APIs don't need internet.
Yes, that is where I was. Yeah, that's one of the question also I had. Yeah.
Yeah. So that answer is probably correct when someone created the answer. So that answer is correct 10, 15 years back. But the answer is still present in Google search results today. So today it is not correct.
Okay. 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 I got
Right?
it.
So
Yeah.
in the interviews also, please don't use such answers because I can easily figure out whether that answer is coming from Google search or from someone's experience. Right?
Okay.
So always I tell anyone blindly don't follow Google search results or AI results like ChatGPT or anything. Your experience is more valuable than artificial intelligence than Google search. So for me, my experience, whatever I feel as a gut feeling, first I will tell it even if I'm incorrect. Second, I trust Google search. Third, I trust AI. And I request you guys also to build that kind of practice so that you show up your confidence.
Yeah.
Sure. Thank
Yeah.
you,
Thank you.
Genevieve, for the message. Okay. So I hope the rest of the team also understood the 3-tier architecture model. And of course, now the question is, how would I share my notes? So I have the list of final participants who enrolled, and probably few more will enroll after this class. We'll still continue chapter 2 right away, but let me take a small deviation for a minute or two. From Monday onwards, guys, the class, no more public sessions. It will be private sessions only for the nominated people. And I will be giving away the notes access from weekend onwards to all those people who have completed their what do you call, the enrollments. Okay, I remember I have shown you the Google Drive, right? So that's what I'm trying to see if I can log in now. Okay, I'll do this later then. There is a big activity I have to follow. So I will be asking you guys on the final WhatsApp group your email addresses over the weekend or maybe on Monday. And then I will share the entire Google Drive notes immediately, which means the entire course training material will be shared with you either on Saturday or Sunday, worst case Monday, once I get the final list. So whatever notes I'm writing, you please ignore it. This is very rough notes I'm writing. I'm not even willing to write more notes here because as I type in, it is a kind of killer, time killer, but minimum things I will be typing it. So this is the end of chapter 1, happily. Right. So what did we discuss as part of chapter 1? A quick recap, if you ask me. We discussed what is an API, what is the data descriptive formats that API uses. Then we discussed about client and server architecture yesterday. And today we have discussed about 3-tier architecture today. That's a quick recap of what chapter 1 offers to us. Now we'll move to chapter 2. Chapter 1 did some good foundation for us so that we know what exactly is API and other stuff. Chapter 2, we will go one step forward to the world of APIs. In this, you don't need too much of intelligence now, very simple topics. The first topic will be that I'm going to talk about is evolution of APIs. Ideally, people say, why, Kiran, you are including this topic? But I always believe that when you are learning something, it has to start from the ground level. We cannot assume that everyone is super intelligent and directly get into the automation testing. Our basics should always be good enough so that when you speak to opposite developers, testers, interview panel, your respect also should be on a higher level, right? That's how it has to be. So evolution of APIs. So API concept didn't exist yesterday or 5 years before or 10 years before. This concept of APIs exists right from the year 1999 or 2000. And probably that's when I did my first engineering, my first year of engineering. So APIs existed when I started my engineering days. And I knew it only in 2012 that the concept of APIs exists. Right, so 12 years I was late to understand it, and today few people are understanding about APIs now, which means they're 26 years back, right? So the way in which APIs evolved is first the technology that came is remote procedure calls. So RPC stands for remote procedure calls. After this technology, another technology came into picture called SOAP APIs. After this, another technology came called REST APIs. After this, another technology exists now called GraphQL APIs. So this is the evolution order of APIs in the internet. And if I talk about XML RPC APIs, it is an outdated technology today. I'll explain about that shortly. SOAP APIs technology is almost outdated. So let me just put it in orange color. It is 90% outdated. REST APIs is a technology that's currently running in the industry. This technology is what every developer uses in any organization, in any country, in any continent. GraphQL APIs is a parallel technology developed recently, and it is following the concepts of REST APIs and advancing a few things. Let's talk a little bit more about all these technologies now. So first I will talk about XML RPC APIs. Okay, so when the industry decided that we need some communication from module 1 to module 2, they came with a technology called remote procedure calls. Okay, RPC stands for remote procedure calls. So let me write it, remote procedure calls. And when module 1 is talking to module 2, or when module 2 is talking to module 1 or module 3, they need to talk in some data descriptive languages such as text or HTML or XML or JSON or YAML. But when XML RPC is introduced, JSON never existed because this is a very old technology in the year 1999, 2000, I guess, or maybe 2001, 2002. Year is not important again. So here, the content type they used is XML. Now, what is content type? I have explained it to you already yesterday in the client and server architecture. Right, I think in the diagram I have added it. That says what is content type? The type of content client is sending to server, or the type of content server is sending to client. Otherwise, what is the data descriptive language? In which language the modules are talking to each other? The answer is XML. So in XML RPC APIs technology, the client and server communicated with XML, or two modules communicated with XML, or front end and back end spoke to each other in XML. You see, I'm explaining more stuff now. When I say content type, I mean module 1 is talking to module 2. That is one way I can explain. Or client is talking to server in the form of XML, or server is talking to client in the form of XML, or the front end is talking to back end in the form of XML, or the back end is talking to front end in the form of XML. Similarly, I can bring in server also here if you want. Okay, so all the communications can be in between modules. The communication can be between client and server. The communication can be between your front end versus back end versus server, right? Now you might say, is there a difference in all these three? Actually, I will say all are same. When module 1 is sending a message to module 2. Okay, let me open my diagrams if I still have it. API, this client and server. Okay, so if you see this diagram, right? Login is talking to logout, or logout is talking to login. So what is logout doing? It is sending a request. Anyone who sends a request, what do we call them? Question to client. Very good. Now, what is login doing? It is giving a response to logout. So when someone is giving a response, what do we call them?
Server.
Server. Okay, so now you told me that logout is a client, login is a server. Very good. Can I also say login is a module and logout is a module? Of course, yes, that's our discussion started. Then if logout is sending a request to login module is going to validate the request. So can I say, since the user is clicking on logout button on the front end application, I can say logout is acting as a front end system, and the login module is checking the database and giving a response. So login is acting as a backend or as a server. So in the same diagram, do you see module talking to each other, client and server talking to each other, front end and backend talking to each other? Of course, yes. Right? So otherwise, I mean, that's why I say whenever you hear the word content type, your mind should tell you that the type of content you are sending from left hand side to right hand side is XML. Who is there on the left hand side? Either a module or a client or a server or a front end or a back end or a database. Who is there on the right hand side? Maybe a module, maybe a server, maybe a client, maybe a front end, maybe a back end, maybe a database. Now you guys tell me, have you understood what I told about content type and this thing that I wrote in the brackets? If you have understood this, then it's a good thing. You'll follow a lot of stuff in the upcoming classes then. Okay, perfect then. So in this particular technology, which is remote procedure calls, the data transmission between any two modules always happens in XML format. And this technology is 100% outdated today, which means no developer in the world today will say, Kiran, we have developed APIs using this technology. That's a gone technology. No one will work on it. So you don't have to be taught by some trainer how to test these APIs, because no trainer is aware of how to test these APIs. Even if they teach you, it is waste of your time. So this is enough for you to know what is XML RPC APIs. But when some technology becomes outdated, for whatever good reasons, some other technology will come and replace it. So that some other technology is SOAP API. So SOAP APIs. SOAP stands for Simple Object Access Protocol. That is the full form for SOAP. Okay, Simple Object Access Protocol. And here also the content type they used is same content type. They use the previous technology content type. And one more thing they added is the concept of HTTP methods have started, and SOAP APIs technology recommends the developers to use only POST method. And as a tester, if you are testing SOAP APIs, you will have to use only POST method in all your API testing process. You cannot use GET, you cannot use post, put, patch, delete. They are not valid in SOAP APIs. Only POST method is valid. So I can say HTTP methods allowed is POST for this technology. And HTTP methods not allowed is the remaining ones: get, put, patch, delete. Please remember that. Okay. And this technology is 90% outdated as of today, and 10% we still have the usage in the industry. Since someone is using it, I have decided to explain this in my course, so that if you are told to work on this technology in the interviews or in the project, you should not be having difficulties. Okay. In fact, I worked on this project when I was working with Philips in Bangalore. So when SOAP APIs became outdated, someone has to come and take it over, right? Then the technology that came in the market is REST APIs. Now REST stands for representational state transfer. That is the full form for REST. And here the content type they used is any format is allowed. So REST came and said, why should I restrict my developers to follow only XML or JSON? Let them use anything, which means XML is allowed, HTML is allowed, JSON is allowed, text is allowed, YAML is allowed, etc. Anything is allowed. But mostly we use JSON in REST APIs. Okay, I can say here JSON is preferred by the developers. If developer is using JSON, in our testing also we have to use JSON only. JSON is a mechanism through which data can be transferred from one module to another module, from front end to back end, or from client to server, or server to client, or module to module one, or front end to back end, or back end to front end, like that. Okay. And here the HTTP methods allowed is all HTTP methods are allowed. Example: get, post, put, patch, delete, etc. I have explained only 5 methods, but we have more than 5 methods. That's why I wrote etc. When I say etc, I can give one example: options, head, echo, tail, trace, debug. So 7 more are there that I know. 7 more plus this 5, 12 methods. So when the developer says I'm using REST APIs, he can use any HTTP method, and you can use the same HTTP method for testing as well. Okay. And this technology is 100% in usage as of today. This is the preferred technology today, not today, from the last 12 years. This is the preferred technology in the industry. Okay. And I'll ask some general knowledge question, but I'll give only 30 seconds time. Can you take a guess who developed the REST APIs technology? Which company developed the REST APIs technology? That company is known to all of you. You use that company every day. Okay, recording is still on. Don't worry about it. It's on. Microsoft, no. You use that company name every day. You open browser and that is what you do. Correct. Google is the company. So Google is the founder, creator of REST APIs technology. So when Google created this technology, Google created it only for Google products, for their Gmail or for their YouTube, whatever, etc., etc. But later Google felt bad about us, so they made it open standard, and they invited the world saying, boss, we created a fantastic technology called REST APIs, use it for your project. So now it is an open standard tool. Now Google does not own it. It's maintained by the open source community. So obviously we should be thankful to Google for giving that fantastic technology. Now, when REST APIs are still in use, another new technology came in the industry. I think it's been close to now 5 years. This technology came called GraphQL APIs technology. Now here QL stands for query language. Query language APIs. And I'll explain what is the difference between all these things. And here the content type, mostly I have used post, but they say all methods are allowed, all formats are allowed. But mostly, people use JSON or YAML. Then HTTP methods allowed, or mostly all methods are allowed. Okay.
Hi, Kiran. What is YAML? I keep hearing that from you in many places. You are telling that one. I have heard JSON, but not YAML.
Okay. So YAML is not a markup language. That is the full form. YAML is another way of transferring the data from client to server, server to client. YAML family is bigger than JSON family.
Okay.
So the difference will be in simple format. See, we all speak English, right?
Uh-huh.
But which English Kiran is speaking? English India.
Uh-huh.
Now, when I speak to my customers from South Africa, or let's say from Australia, they speak English Australia. If I speak to someone from London, UK, so they have Great Britain. If I speak to someone from United States, they speak English United States, but still the language is English. But still we have the differences saying, okay, Kiran, your English is good, but you speak in Indian accent. Someone says, okay, you speak in UK accent or US accent. End of the day, it is the same, but the way you pronounce things are different. The way you construct a statement could be different. Similarly, JSON and YAML also have similar differences. I'll give a simple difference. My difference may not be 100% correct. Here you follow key value pair, right? In JSON, you follow key and value pair. So this parenthesis is mandatory. This double quotation is mandatory.
Yeah.
In JSON.
Object is mandatory. Yeah.
This format you see is mandatory in JSON. Whereas in YAML, they say parenthesis is optional.
Okay.
And I can directly write key value. I don't need this double quotations. So the same data is going from client to server, but the syntax is different between JSON and YAML.
Okay.
In another way, YAML says, okay, you can write the key here. The value will go like this. Meaning you cannot write value like this also. You have to give one tab and then write the value. This is another way how the data is written in YAML format. End of the day, it is a language to transfer the data from one module to another module. So the syntax is different, but the concept is same.
Okay. Thank you.
Yeah. So GraphQL APIs I have told, and this technology is new in the market. Maybe 40% of the companies are using it, meaning they have adopted this new technology and started using it. And I can also say it is an advanced version of REST APIs. And again, general knowledge question, which company do you think is the founder of this GraphQL technology? Again, I can say that everyone is aware of that company name, and that is spoiling everyone's time. Dash is the founder of GraphQL Tech. Of course, yes. So Facebook is the founder of this technology. Again, initially Facebook developed it only for their Facebook products, but now they made it open standard. Every company can use this now. Now the question is, what is the difference between GraphQL APIs and REST APIs? I'll give a simple example first. Later, I'll give a technical example. So think of REST APIs like Kiran going to a restaurant and preferring buffet or buffet system. So where there are a lot of vegetarian food, non-vegetarian food. Maybe there are 40 dishes in the restaurant. I go to the restaurant with my family and I pay per person, even if I don't consume the entire food that they are presenting it on the table, right? There might be 40 dishes, but I don't eat all the 40 dishes. Even you won't eat all the 40 dishes. You will try max 5, 6, 7, 8. But still you end up paying that 1,000 rupees per person. So if I go with my family, I have to end up paying 6,000 rupees per dinner, which is useless according to me. So that buffet system is like REST APIs. Next time when I go to restaurant with my family, I understand a lesson.
Kiran, it is breaking. Your voice is breaking, Kiran. Is this for me alone or for others? I don't know.
Yeah, it is breaking actually.
Okay.
No, it's breaking. Even I too.
Yeah, it's all.
Yeah, we missed the last things what you
Okay,
said.
it's breaking. Okay, 1 second. Let me see if my network is stable or not.
So right now it's fine, but for a few minutes before we did not hear anything what you said. Now what you are talking, we were able to hear you.
Okay, fine. So I'm saying this REST API is like Kiran going to a restaurant, having buffet and spending a lot of money on the buffet system for his family. But Kiran knows the fact that we are not eating everything, but still I end up paying the full amount per person, right? So assuming 1,000 rupees per person, I end up paying 6,000 rupees for 6 people, right? So REST APIs are comparable to a buffet system. So next time when I go for a dinner with my family, what will I do? I remember my previous experience of wasting money. So I will order a la carte system, meaning let the waiter come in and then he says, what do you want? And I will say, okay, get me dish one, get me soup one, get me ice cream one. That's it. When my family says, okay, we are done, our appetite is done, I will say, okay, check or bill. And then I end up paying probably 2,000 rupees. But still, our appetite is filled, our hungriness has gone. So I'm saving 4,000 rupees here if I go for appetites a la carte system. So GraphQL APIs are comparable, and this technology is comparable to a la carte system. Have you understood this restaurant example? First of all, everyone?
Kiran, if you don't mind, could you please repeat that? This GraphQL once again.
Yeah. So all I'm trying to say is REST APIs technology is same as having buffet lunch or dinner, which is expensive, whether you go as a single person or as a family. And if you go for GraphQL APIs, this is like a la carte system, where you order what you want. And this is economical or cheap, I would say. Right? A la carte is like you order, let's say, one soup you order, one biryani you order, that's it, you are done. So you hardly spend 200 rupees in a la carte system or 300 rupees, but in buffet lunch you spend 1,000 rupees, which is expensive, right? So this is from a lunch perspective I'm telling. Now let's come to little technical perspective. REST APIs are expensive because they consume lot of CPU resources and server. Simply I can say lot of server resources. Why will it consume lot of server resources? I will answer it to some extent. So REST APIs consume lot of server resources, hence it is operationally expensive. They are operationally expensive. Because on the cloud, you pay per usage. If I'm using the server for 5 minutes, I pay for 5 minutes. When it comes to GraphQL APIs, here optimal utilization of server resources happen, which means it is operationally inexpensive. Meaning, if I'm using REST APIs to achieve some task, I might need 5 minutes of server. So I have to pay for 5 minutes of server. If I achieve the same task using GraphQL APIs, I can complete it in just 2 minutes instead of 5 minutes. So I end up paying only the cost for 2 minutes to AWS or Microsoft Azure or Google Cloud. That's why if you Google also, you will see the same thing. Lunch example to compare REST and GraphQL, and REST APIs are operationally expensive because they consume lot of server resources. Don't worry about why will they consume lot of server resources. That's what developers to worry about. GraphQL APIs consume very less server resources, and hence they are cheaper, operationally inexpensive. Again, if you say why GraphQL APIs are occupying or consuming less server resources, don't worry. That's not for you. That's for developers to worry. But still, I will answer that question. Why more server resources for REST? Why less server resources for GraphQL APIs? So again, I'll give a simple example. So I will probably take one of you as an example. Maybe Madhu, you are raising your hands. I'll ask you only. So assume that I'm interviewing you. You just give me some answers, okay? So when I say, hey, Madhu, tell me something about yourself, right? And then probably you open up your mind and then you say, hey, Kiran, this is Madhu. I've been working in IBM for the last 3 years. So this is what you are saying. Your name is Madhu. You have got 3 years experience. You have been working with IBM. And you told me something about your skill set A, comma, B, comma, C, comma, D. And then you spoke about your education. You spoke about, your current salary. And you spoke about your expected salary. And you spoke something about your family details, maybe in the interview, right? So this is what Madhu started speaking to me in the interview when I said, can you please introduce yourself? Now, this is first round of interview, that too a technical round of interview with Kiran. So when Madhu is telling all this information, Kiran makes a note of only the information that he wanted. So Kiran says, I don't care about your current salary and your expected salary. So what Kiran does, he will strike it out from his notes and also from his mind. And Kiran says, I don't care if you're coming from IBM or Microsoft or a startup, because knowledge is important, right? And probably coming to family details, maybe HR will do that verification about family details. Kiran in the technical round will say, I don't worry too much about family details. That's for HR team to worry about. So for Kiran, what is important? The experience he's coming with, the skill set he's coming with, and probably education also matters sometimes. But did I inform Madhu that don't talk about your company name, don't talk about your current salary, experience, family details? No, I didn't, because it does not look good if I stop him. At the same time, when Madhu is talking about IBM, he is spending his energy, right? When you speak, you spend energy, right? At least 0.003 calories are burnt when you speak. So I'm killing your energy because I'm not even updating you that I don't need this information. Right? So this spending energy by Madhu is nothing but lot of server resources. Since I'm draining you out of your energy, it is operationally expensive. So when Madhu is tell me something about yourself, when Kiran is not restricting, it is like using REST APIs. Next time when I interview Madhu in another company, I will say, hey Madhu, can you just talk about yourself? I'm more interested in your skill set and education. That's it. Then Madhu will not talk about his current company. He's not talk about all these things. He will simply say, hey Kiran, my name is Madhu. I have got 3 years experience. I know A, B, C, D tools, and I'm education, and this is what I'm, and I'm graduated. Perfect. Very simple. So this is where I'm optimal utilization of his energy levels. He is not spending his calories. So this is saving his energy levels. So this is inexpensive. This is what happens in GraphQL APIs. So the API that you are testing, which is developed by the developer, the GraphQL, so the REST API is like beating around the bush. GraphQL API is like point to what you want. I'll give an example. So I will say I'm writing an API. It's okay even if you don't understand it. Theory is what you should understand. I will say kiran.com/ education ? So if this is my API, okay, instead of Kiran, I'll say Madhu. So get the education details of Madhu. If this is the REST API, the output will be . it might say he completed his 10th standard, he completed his 12th standard in so and so college, so and so school. Then he completed his graduation in so and so university. Then post graduation, not applicable. Maybe he did not do it. This could be the output from REST API. Then Kiran says, why am I worried about 10th class, 12th class? I'm just interested to know whether he graduated or not. So this green color stuff is what Kiran is interested. But a database is giving me a lot of data from the database. And to give this data to the user, database is executing the query. That query is executing the server resources. So it becomes operationally expensive. And when this entire data is presented to the front end system, to the module, to the user, user says, I don't need 10th class, 12th class, I need only graduation. I'm wasting the data given by the server. Just like in buffet, I'm not eating non-veg food 1, non-veg food 2, veg food 3. I'm eating only salads. Then I'm wasting my 1,000 rupees on it. So that's how REST API output looks like. But if you develop the same thing in GraphQL APIs, you will have the flexibility here saying, I'm just giving a dummy example only. ID equals to, or I can say something like graduation. Okay. Or it looks something like this. Query equals to only graduation. Then my output will be this only. Because I'm telling the database that I'm interested only in graduation level details. So it will not give me anything about 10th standard, 12th standard, post graduation. It will give me only what I wanted. So this is like a la carte system. Like I'm telling the waiter, get me one biryani, one soup, one juice. That's it, period. I get what I want. So in this way, the database is not utilizing maximum server resources. It is going to the DB, picking the record that you want. In a more simple language, REST APIs are like select star from table. It will give all the data. Whereas GraphQL is like select star from table where some condition. This is another way to make it clear for you guys, the difference between GraphQL APIs and REST APIs. Okay. So this is about the evolution of APIs. In the next class on Monday, we will talk about classification of APIs. Then we'll talk about syntax of an API. Then we'll talk about public examples, public APIs on the internet. I'll show some examples. With this, we'll complete chapter 2 in Monday's class. Okay. I'm open for questions before we sign off for today. Okay, Madhu, your hand is still up. Let me know if you have a question.
No, Kiran, I'm fine.
Perfect. Thank you. Okay, then guys, so we have completed chapter 1. Chapter 2, we just started. We discussed about the evolution of APIs. XML RP APIs is outdated. Forget it. SOAP APIs is almost outdated. Don't forget it because I'm teaching a project 2 in this for SOAP APIs. Then REST APIs, which is very important for you to learn. That's my project 1. That's my project 3, project 4 also. And GraphQL APIs, companies they have started to adopt it. We will see if we can touch base it, but Postman can test all these technologies. Okay. So if you have made up your mind and not yet completed your enrollments, until Monday evening is when you have the times to take the final decision. Monday, no more public sessions, guys. I'm just telling you as a message. And all the notes will be shared with you guys. And the recordings will be available only for the enrolled participants from Monday training onwards. So Monday we have class. Please ensure you join. Monday to Friday, every day 1 hour without any misses. That's all then, guys. Thank you for your time. I'll see you on Monday. Take care. Happy weekend.
Or REST as your board?
Postman.
Okay.
This course uses Postman, Newman, Jenkins, Postbot, Git and GitHub. Rest assured, this is I mean, we are not teaching rest assured in this batch. It is purely Postman API level automation.
Okay.
Thank you, Kiran.
The
Really
answer is
wonderful.
yes, Shobna. Sure. Thank you, Kotai.
Yeah.
Yes, Shobna. Everything can be automated with AI, and you'll understand how in our course. Thank you, everyone. Take care. Happy weekend. Bye-bye.
Happy weekend. Bye.